In this video, we're going to look at the CSEC Math January 2024 Paper 2, Question 3. So here we have Question 3 Part A. We have in triangle ABC, AC is equal to 8 centimeters and BC is equal to 5 centimeters. Now let's say using a ruler and compass only, construct triangle ABC. The line AB has been drawn for you. Now, I want to address this point that the line AB has been drawn for us. Now, I am on the computer. I would have cropped the picture of the line AB and pasted it onto the whiteboard. Therefore, the length of the line AB on the computer would be different from the length of the line AB on the actual past paper. So when I construct the triangle ABC here on the computer, it's not going to be the same size as the triangle ABC when you construct it on the actual past paper. So I just want to make that clear. So if they ask us to measure any angle or anything like that, you're not going to get the same answer as if it did it on the actual past paper. But the method that I'm going to use is going to be the same, and you're going to see all the steps as to how to get the right answer. So because we have the line AB already drawn for us, we have the line segment AC now. This is construction. So you're starting at A, ending at C, and that line has to be 8 centimeters. So therefore, from A to some point C has to be 8 centimeters. So here I have my ruler and compass. I'm going to take the compass, place the point of the compass on the zero of the ruler, and I'm going to open that out to 8 centimeters. So my compass is opened out to 8 centimeters. Let's move the ruler. I'm going to take the compass point and place it on the point A. And I'm going to make an arc using a light line. Then I'm going to look at the line segment BC, which means you're starting at B and ending at C, and that line segment is 5 centimeters. So I'm going to take my ruler again. I'm going to take my compass, place the point at the zero on the ruler, and I'm going to open the compass out to 5 centimeters. Then I'm going to take the compass point, place it on B, and I'm going to make an arc to intersect this arc here. Now, the point where these two arcs intersect would be the point C. So now, all I have to do is draw a straight line from A and connect it to C, and draw a straight line from B and connect it to C, and that would be my triangle ABC. So I'll move my compass. And of course, while I'm constructing, I'm using light lines. So what I can do is just draw a straight line straight through C, like that. And then from B, I make this light line straight through C again, like this. And now this will be my triangle ABC. And once I'm satisfied with the diagram, I can darken the light lines. So I'm just darkening from A to C and from C to B. And this would be my answer. Now for part 2 of the question, we have measure and state the value of the angle BAC. So we know the angle is located at the letter in the middle anytime we use 3 letters to represent the angle. So BA is going to be an arm of the angle and AC is going to be the other arm of the angle. So let's go. BA is one arm and then AC is the other arm. Therefore, the angle is located at A. Therefore, we want to measure this angle here. So again, BA, that's B to A, and then A to C. A to C. The angle is located at A, the letter in the middle. So here I have my protractor. I'm going to line up the center of the protractor with the arm of the angle AB. And now this arm of the angle AB will be my 0 degrees. So I look on the scale, the outside scale and the inside scale, and see where the 0 degrees lines up with the arm of the angle AB. And we've seen that will be the outside scale. The 0 is here on the arm of the angle AB. So now I go all the way around from the arm of the angle AB to the arm of the angle AC. So if we go all the way around like this, we see we are lining up with about 37.5. If I use the magnifying glass, let's see. So here we'll have 30. We have 31, 32, 33, 34, 35. And then here's 36. And 37 will be somewhere here that the line is kind of blocking. And this next stroke here will be 38 degrees. So it's between, because watch, 38 here, then here will be 39, then 40. So this line here is 38 degrees. All right, so it's a little under 38 degrees. So approximately 37.5. So angle BAC is equal to 37.5 degrees. Now, I'd just like to remind you again that if you're doing this question on the actual past paper, the exact copy of the past paper, you would not get this answer because my length of AB here would be different from the length of AB on the actual past paper, which would affect the angle at BAC. But the steps that I've taken to actually do the question would be same. So once you have the actual past paper, let's do the same steps, measure the angle, and whichever angle this line falls on, you just read it off and state the answer. So now we're moving on to part B of the question. We have the diagram below shows an equilateral triangle. We have FGH. So FG to H is an equilateral triangle, which means the length of all the sides are equal. So if here's 13, then here's also 13, and here's also 13. Let's put that in. So here's also 13 centimeters, and here's also 13 centimeters. So we have FGH, whose base is 13 centimeters, so we saw that, and its height is H. So H here is the height of the triangle. And as we know, height and base of a triangle must be at right angles to each other. And now what they want us to do is calculate the value of H, which means let's find the height of the equilateral triangle. So what we could do here is we could split this equilateral triangle up into the two equal right angle triangles. Or I could say the right angle triangles would be congruent because they would be exactly the same. So here I have one side of the equilateral triangle. So this would be H on top here. Here will be G. And this would be my height H. Of course, the length of the side is 13 centimeters. And now think about this. This line here will cut the base in half. So the length of F to G is 13 centimeters. Half of 13 is 6.5. Therefore, the length down here would be 6.5. So here's going to be 6.5 centimeters. And that's because this height split this base in half. So what we have is 6.5 centimeters here and 6.5 centimeters here. Two equal right angle triangles. So now we have a right angle triangle. We have two sides given and one side missing. And that tells us we have to use Pythagoras' theorem to find the missing side. So first we're going to identify what is the hypotenuse, which is the longest side on a right angle triangle, or the side opposite the right angle. So you see I drew a line from the right angle. It touches this side, and therefore HG is the hypotenuse of the triangle. So I'm going to put hypotenuse here. Now Pythagoras' theorem states that the square on the hypotenuse is equal to the sum of the squares on the other two sides, which would mean 13 squared, because that's the square on the hypotenuse first, is equal to the sum, which means to add, of the squares on the other two sides. And the other two sides are H and 6.5. So we're going to square the H and add it to the square of 6.5. So now what I could do is transfer this positive 6.5 squared across the equal sign, and it will change from positive to negative. So we have 13 squared, take away 6.5 squared is equal to H squared. And now I could work that out on the calculator by saying 13, press the x squared button to square it, take away 6.5, press the x squared button to square it, press equal, and we get 126.75. So I'm going to have 126.75 is equal to H squared. And if I want to find H, I'll have to find the square root of 126.75. So I'll go to my calculator, and for me, I have to press second function and then the x squared button for the square root to come up. And then I put in that 126.75. Press equal. Now this answer is not exact, and unless the question tells you otherwise, you have to write these answers that are not exact to three significant figures. So 1, 2, 3. The 2 is the third significant figure. after it is a 5, therefore 2 goes up by 1 and turns to 3. So 11.3. So I'm going to have h is equal to 11.3 centimeters. So here I'm just going to state my answer. H is equal to 11.3 centimeters. So now moving on to part C, we have the diagram below shows 3 triangles, P, Q, and R. So here we have P, we have Q, and we have R. Triangles Q and R are images of triangle P. Therefore, triangle P is my original triangle, the object, and these two are images. Alright, so we have triangles Q and R are images of triangle P after it undergoes a double transformation. So here they want us to describe fully the single transformation that maps triangle P onto triangle R. So P is the object, R is the image. Now if you're looking at P and R, we've seen that P and R are looking exactly the same size, it's in the same orientation, and anytime we have same size and same orientation, we think translation, which is a slide. So let's see how triangle P has been translated horizontally and vertically. So we could choose any point. We could choose this point on top here. We're going across 1, 2. So that's 2 on the horizontal, and 1, 2, 3, 4, and 4 on the vertical. We can check the other points. Let's check this one here. So object, image, 1, 2. That's 2 on the horizontal, and 1, 2, 3, 4. 4 on the vertical. We can check this point here as well. Object, image, 1, 2, and then up, 1, 2, 3, 4. So we know going to the right horizontally is a positive number. If you was going to the left horizontally, that will be negative. And going up is positive for the y. If I was going down, that would be negative for the y. So my answer here would be a translation with translation vector. And the translation vector, I place the x component at the top and the y component at the bottom. Now the x component is the horizontal shift and the y component is the vertical shift. As we said, the horizontal shift was positive and positive 2. And the vertical shift was going up by 4, which would be positive 4. Now for part 2, we want to do the same thing. We want to describe fully the single transformation that maps triangle R onto triangle Q. So we want triangle R as the object mapping to triangle Q as the image. Now when looking at these two triangles, we've seen that they are not in the same orientation. So it cannot be a translation. But what I notice about R and Q, it's laterally inverted. And anytime I see lateral inversion, that tells me it's a reflection. So now I have to figure out where's the mirror line. And we know the distance between the object and the mirror line must be the same as the distance between the image and the mirror line. And of course, the line connecting the object to the image must be at right angles to the mirror line. So if I were to draw some lines connecting the image to the object, we are seeing that all the lines connecting the image to the object would be at right angles to a vertical line. So now let's find what is half of these lines. So on the top one here, we have 1, 2, 3, 4 blocks. So halfway will be 2 blocks. That'll be here. Let's look at this one. 1, 2, 3, 4 blocks again. So halfway will be 2 blocks. This one will be 1, 2, 3, 4, 5, 6. Halfway will be 3 blocks. So 1, 2, 3. Therefore, this would be our mirror line. All right, this will be my mirror line. Okay, and this mirror line, look at where it touches the x-axis. This is 0 here, this is 2. So halfway between 0 and 2 will be 1. So this mirror line touches the x-axis at 1. Therefore, the equation of the mirror line is x is equal to 1. So mirror line, x is equal to 1. So what we have here is a reflection in the line x is equal to 1. So for my answer, I'm going to put reflection in the line x is equal to 1. And now that will bring us to the end of this video, and stay tuned for the other question, which will be question 4.